Thank you very much. Can you hear me? I've got laryngitis, and weirdly, the last time I had laryngitis was when I was giving a talk about 6 years ago here on core logic, and I remember that being a really bad day. So maybe it's something to do with the crypt, or anyway. Let's put this on. That's all right. It's okay. I did quickly look at the NHS website about what I should do about laryngitis, and it gave me the advice of try to speak as little as possible. Yes, and well, that's right, exactly. and so this won't be a very long talk, but when I run out of words, then we can go to the pub. Okay, so this is a talk about computers. Most of my talks are about computers. This is really about the fundamental things that computers do. When I did computer studies at school, they told me computers did three things. That was input, data, process it, and output. And kind of a joke that I make quite often is that many languages only do one of these half well. So there's something foundationally wrong with our industry. So I'm going to pick on Java. I'm going to pick on three data formats. Java serialization, I'm going to explain about what that was, XML and JSON. So I'm going to pick on Java here. I was programming Java in around 1995 when it came out, and in 1997 they produced a thing called Java serialization, which was this wonderful pure silver bullet for data serialization. And what it meant was that you could create, it was going to make all the problems of I/O disappear, and you could just decide, you were going to just read in and out of the disk without any code. This is what it looked like. I had some experience in enterprise Java beans, which was a wonderful technology. So this is why there's some bias. But in Java, in enterprise Java beans, if you wanted to create a deployment descriptor, the first version of enterprise Java beans, it looked like this. You had an API to the data model, and you would create enterprise Java beans deployment descriptors in code. You'd have to mark your classes serializable, and you would also have to give it this serial version ID. More of that in a minute. When you were writing data, all you had to do was create your class model, your object model. No, there's no real Java data literal syntax in Java. It's not very easy to do. So, in many languages, it's still like this. That you create an object output stream, and then you write to the stream. Reading data is quite similar. You just create an object input stream, and you read your object back up. Only if your object had changed at all, or if you changed your object model or anything, then what would happen? Boom, you'd get an error. So it kind of didn't do version evolution very well. In fact, it did it really, really badly. It was completely brittle. And I think when Sun released this, a few seconds after they've released it, they thought, gosh, what have we done? This is terrible. And it is terrible. In fact, serialization is still in the JVM, and I think they really wished it wasn't. So you're 1999 or 1998 here. What are you going to do about it? So you quickly scramble around and find some alternative. XML to the rescue. This is what a deployment descriptor looks like in XML. And XML, I think, is a huge advantage over what we've just seen. It is language independent, it isn't tied to Java, and it has a good versioning story. But as you can see, it is still a descendant of SGML, and it is much more tuned towards documents, or sort of paper documents, and you can see that by it's really, really verbose. It uses these tags that were kind of meant to mark up sections of text. So it's not the best data format. But still, it still has, it's still worth talking about. There was a thing called XML schema, which allowed you to create types and create constraints on XML, so you can begin to create shapes on those XML documents. And here we have a declaration saying that we want to have 7 different sub-elements, and these are the types. It's Boolean at the end. It also had a pretty good language called XSLT, which was a bit of a toy language, but it did 3 things really well. You could load in XML, you could process it, and you could output it. In fact, it was so easy to input and output, you just didn't have to do it, you just declared these style sheets. How many of you have ever coded in XSLT? Okay, it's really good for a set of problems. Unfortunately, that set of problems is quite small. So we needed to integrate XML into our programming languages, and so they invented something called the DOM, which, if you've ever seen how to do this, writing in the DOM is awful. It's a terrible API. You start off with a horrible, mutable data structure. It's one big kind of global variable. And really, that was the best that we had. So I think XML had a lot of things going for it. But unfortunately, the language integration was really, really poor. And I think that's what everybody felt. Yes, it was horrible to type, but the worst thing is we just didn't have good programming language integration. So I remember the Lisp community, which were kind of on an island a long way away, were kind of looking at all this from afar in their ivory tower and thinking, well, everyone's really stupid. Why don't you just use S expressions? And in a sense, we are. The world outside of the Clojure community has kind of stumbled across this thing called JSON, which I had a bit of an epiphany last year about this. I was thinking, well, you see JSON absolutely everywhere. And I used to hate it, and I can kind of moan about it. But when you get down to its core essence, this is what JSON is. It's just lists and maps and maps and lists and lists. And we know this stuff. This is the data model that we used to. This is our bread and butter. So surely this is an advantage to Clojure developers. We just know how to process this stuff. So the fact that the whole world has adopted this as their main data model is an incredibly fortuitous advantage for us. Here's an example of some JSON, if you haven't seen it. Now, I would, this is, or just AWS CloudFormation could be any JSON. I thought it would be really nice if you could add a comment there. Because I think one of the things, who's got children here? I've got kids, I love them. I think it's a terrible thing we're leaving to our next generation is all this config with no comments. What a hospital pass. But in fact, I kind of made my peace with this. I kind of realized that actually the reason why JSON doesn't allow comments is that it really wants you to do this. Now, there's a subtle difference between that and this. And this one is preserved in the data model. So if you're writing some sort of UI in order to process and adapt and modify the data and you want to save it back, you don't have to worry that all the source comments have disappeared. You don't really have to worry about the formatting. And it's kind of odd, if you think about it, why we have this anyway. Why we've got a kind of clean syntax, and then we suddenly go to this white space oriented slashes, or in XML it's or in Clojure semicolons. And why do we do that? Why couldn't comments, especially in data, be in data? So I kind of discovered, well, okay, all the things I hated about JSON, I kind of made my peace with. I think, well, actually, it's a really good format. JSON is ubiquitous. I kind of challenge you to go and find a microservice somewhere or some sort of service on the web that isn't producing JSON. I was really keen that everybody use different HTTP content negotiation, but the only content that most APIs negotiate, would ever need to negotiate, is JSON, kind of very, very few microservices or web services out there to anything other. And it's a very kind of organic thing. Everybody in every language has discovered this thing, and they're all talking with JSON to each other. So we've got this amazing language I want to introduce called JSON script. It's really easy to slurp in JSON into this language. The memory model that's mapped is immutable by default. That's crazy. It's got an amazing library of functions to process that data, and it's super easy to send and communicate and serialize that data back out. This is incredible. It's very similar to Clojure, but I don't know if you, this is something I discovered fairly recently, that things like destructuring. So JSON has this constraint that all of the keywords would be strings. So I kind of thought that mucks up the destructuring, but it doesn't, because you can still destructure it with this keyword. So you can almost slurp in a JSON document. And I would discourage you from trying to change strings into keywords and back and muck around with the model and trying to kind of use camel case and these converters. Just keep it as it is and don't lose the fidelity. So, yeah, Eden. What do you think about Eden? Well, Eden is better. Obviously, it's better. Comments, real comments, but as I said before, we can have comments in JSON. Tag literals, I kind of think, okay, it's a developer convenience that I can put dates, like hash inst, pretty quickly. But all it does is really save typing, and kind of typing isn't the thing that we spend all our time doing. It should be thinking. So don't mind so much that there is a little bit of an encumbrance on the ergonomics of writing JSON, because it's pretty small and it's pretty flexible. So we could perhaps lose tag literals. And so I kind of realized that Eden is really just JSON with bells on. And we love bells, but maybe, just maybe, this is what we look like to other language communities. I hope not. So I kind of got into JSON quite a lot recently, and I want to kind of, it's partly through experience I had on a project this year where we used JSON schema. So I wanted to explain what JSON schema is, just to get you a kind of taste for this. This is a very easy JSON schema. I want you to think, if you've used prismatic schema or Clojure spec, this is very, very similar. What we're saying is that a map has to contain two entries, foo and bar. Well, it could contain more, but if it contains foo, we want it to be a string. If it contains bar, we want it to be a string, but we must require foo. Bar can be in there, and lots of other things can be in there too. So it is kind of open for extension, a bit like Clojure spec. It doesn't force you. Here's another example where we have min and max length. Now this says that foo, we said it had to be a string, and now we're layering on an additional constraint that it has to have a minimum length of 3 characters. We're also adding an additional constraint saying it has to have a maximum length of 10. Now, these constraints can be there or not. They can be layered on. And so from that point of view, we've seen this before. This is what we mean by simplicity. All of these constraints are independent of each other. There are a couple of exceptions to that rule, but if you read the JSON schema specification, they make this point very clearly early on, that not only are these assertions and constraints independent, you can actually come up with your own vocabularies to just, if you wanted to add your own constraints. For example, you might decide that a particular data item, like a credit card number, needs to be sensitive and stored or encrypted or masked out in certain circumstances. You can make those declarations aren't in JSON schema itself, but you can make them through your own vocabulary. So there are some alternatives to this. Prismatic schema and Clojure spec are the ones that we use internally in the Clojure language. But I think the key there is the word internal, because I believe that data isn't something that should be bound up and caught up inside the process of a machine. I think the point of data is to communicate it. So if it's not communicated, then we're just talking about a tight system here. With schema, it's all about externalizing the data and communicating with other systems. So this is really, the core of what data is. Otherwise, what's the point? So data should be language independent. We shouldn't come up with a data format that is tied to our own language. We need a flipping of a language independent data format, and we need to use it. And JSON schema really, for me, is not just a validation, really has at its core, it's a metadata system. And we're, in the world of data, we're entering, the next few years will be very much around the provenance of data, regulation of data, security of data, data privacy. All of these new problems that we're going to have to solve are problems at the metadata level. So we really need to get really good at understanding how to describe our systems at the metadata level and processing it. And I can't think of a better language to process data and metadata than Clojure. It does help that the metadata in JSON is also written in JSON. There are systems like GraphQL for which that isn't the case, where GraphQL has its own schema and you have to parse it. It's really nice that it's quite easy to process metadata or JSON schema, and that can be used very flexible systems. I'll just give a quick, I believe that JSON and JSON schema are so important that we shouldn't just create wrappers to these things. Like there are these, Metacin have a great library called Spec Tools, and there's kind of like the idea of producing or generating a facade of JSON schema for other systems to produce. I really think we should embrace it natively, a bit like we used to use prismatic schema, and use it for any data that may be externalized to another party. And so for that reason, I looked around and I couldn't find anything that was really Clojure-like and immutable. So Jinx is a JSON schema processor in Clojure. It's fairly new and it's kind of in alpha, but we put that together this year, and it's kind of work in progress. So I'll leave you with this idea of coding at the level of metadata. I think there's so much waste that is done in coding today. You see this all the time, people handwriting, handcrafting code, handcrafting forms, input ingestion, handcrafting. It's everywhere. And in fact, we've almost fetishized it. There's obviously, I have a lot of, the software craftsmanship movement is very important, that it kind of has told us the importance of doing the job working and having skill and improving our skills. But the idea that the skills are, the phrase, a bad worker blames his or her tools, kind of gives the impression that the tools are unimportant and really it's the skill that is important. But I actually think that the skill with our tools, the tools are actually very important as well. They kind of both have this kind of equal relationship. And so I think it's incredibly important that we choose the right tools and that we look to industrialize what we do and not kind of try and write the most perfect code, but just try and solve bigger problems. And to solve bigger problems, we need to code at the metadata level. A colleague of mine once kind of gave his throwaway remark that said that really, as programmers, we should only be writing interpreters and compilers, which kind of is this idea that we should just be designing our own DSLs, perhaps, or writing our own, working at the metadata level, where you're compiling the metadata to produce perhaps other metadata, or you're writing little machines that can process, rather than just kind of handcrafting everything. And I think this is captured well today in Andy's remark. We really want to make computers do the boring stuff, so as programmers we do the interesting stuff. So I'll leave you with this. One of the things that we've been using JSON schema for is a nice little tool called React JSON Schema Form, which takes just a pure JSON schema, embellishes it with some UI hints, and is able to generate, what you see on the right is entirely generated by the data on the left. Now we used this on a project in a bank earlier this year, and for various technical reasons we decided we couldn't use this library. But guess what? Because we had ClojureScript, we were able to very quickly recreate this library or recreate what we needed based on working at the metadata level. And so that the forms that we were generating, we could create thousands and thousands of forms just from the data description, which we didn't own, it was coming from a third party. But we were able to create kind of a form that allowed the ingestion of a whole set of banking products, very, very customized, with nothing more than the metadata. The thing is, it's an incredibly powerful idea, and I think this is why kind of we need to get beyond like coding at the level of objects or coding at the level of individual data elements, and we need to shift up the gears. And I'll leave you with a couple of summary points. So, coding Clojure is fun. I found there's nothing more fun than sitting down with a blank namespace and like learning something new. I think one of the key things that have drawn us all to Clojure is it's fun. But I think sometimes, it's time to get off the island. Was going to mention Wonder Woman. Wonder Woman's got the kind of amazing kind of skills and things, and she lives on an island and in some ways, us as a Clojure community, we're living on that island. But does Wonder Woman, does she stay on the island? No, when there's a crisis, she gets off the island and starts fighting in the trenches and kicking ass and killing, bombing and saving people. So I mean, it's something that we should bear in mind that we have these amazingly effective tools, and we should integrate with other language communities. We shouldn't stay on an island. We should actually engage with the world and use these tools for an effective good. Okay, and we're very privileged to have a Clojure language. It's an amazing tool. It's been a great conference, and I think Clojure definitely has another 10, 20, 30 years of kind of maturity, and we'll be here hopefully in the next 10 years. So thank you very much, and we're going to go for a drink. Oh yeah. Thank you very much.